Today, we're going to build a minimal ChatGPT-style app for iOS using llama.cpp, running on AI model entirely on device. But the goal of this video isn't just to build a chat app. This is really about creating a starting point, a reusable foundation for building many different kinds of AI-powered iOS apps that work offline, preserve user privacy, and don't rely on cloud APIs. Once you have this set up, you can build things like AI note-taking apps, document analyzers, personal assistants, and so many more, all running locally on the user's device. And to make this even more interesting, I'm not going to write the code myself. Instead, I'll be using an AI coding assistant to write the code for me, from the C++ bindings to the Flutter UI. Alright, let's get started. First, let's create a folder for the project. I'll call it iOS Chat. The first thing I'm going to do is clone llama.cpp, since we'll be deploying an AI model locally on the target device. I'm going to use VS Code extension called Cline as my AI coding assistant, but there are other options like Cursor, Windsurf, and so on. For my setup, I'm using the Claude Sonnet model. In the llama.cpp examples folder, there is a minimal ChatGPT-style program called Simple Chat. This is a single file implementation, less than 200 lines of code for a command line chat using the llama.cpp library. You can launch it by providing a model, then start typing prompts and get responses. That's it. This is exactly what we want to build, but with a Flutter UI on top, running right on the iOS device. What we want is abstract away the low-level llama.cpp API and come up with a very high-level chat interface with just 3 functions. Create a chat with a model, generate a response from a prompt, and destroy the chat. So that's exactly what I'm going to ask the model to do. First, I'll write up the instruction here so it's easier to edit. My instruction basically asks the model to read the simple chat implementation, define a high-level chat interface in libchat.h, and then implement it in libchat.cc. I'm also asking the model to write a chat.cc file which replicates simple chat but uses the new chat API. This will let us validate our library. Alright, let's copy and paste this into Cline and see what the model does. I'm giving the AI more autonomy here, letting it write files without my approval, so I can just sit back and watch. Okay, the model is writing libchat.h, then libchat.cc, and finally chat.cc, exactly as instructed. All of these files were generated in a single pass. Let's see if it compiles and runs. Actually, before that, I'll adjust the include path here, though it's not strictly necessary. Alright, don't forget to specify the include paths and the build succeeds. That's impressive. After specifying the library path, the chat runs successfully. Let me confirm this is a continuous chat session. Yes, it is indeed. Perfect. The AI successfully wrote all these files in a single pass without any errors. Very impressive. Next, we are going to target the iPhone simulator. Actually, before that, there's one extra step that will make linking much easier later. I'm going to disable all versioning in llama.cpp so it produces a single dynamic library file without symlinks and version numbers. I'll share a link to the diff patch in the description below, but basically remove all lines setting the so version in the build scripts. Okay, I have manually created a build script that targets the iPhone simulator environment. The actual iOS device should be very similar. It compiles llama.cpp for the simulator, then builds the libchat library, and finally generates Dart FFI bindings for the chat API. For more details on the Dart FFI and Flutter, check out this video. Now let's verify that the build script runs successfully. The script auto-generates the Dart binding code in the lib directory. Alright, now let's generate the Flutter code. I'll initialize a Flutter project in this repo and clear out the main.dart file. This instruction is much simpler. I have already provided the chat interface in C and Dart, and I'm asking the AI to write the Flutter chat UI, assuming there is a model.gguf file in the asset. Let's copy and paste the instruction into client and let it do its thing. Okay, it's first editing pubspec.yaml file to add dependencies. Now it's writing main.dart, that's the first pass, and now it's doing a second pass, editing pubspec.yaml file again. It's also editing main.dart again. Now it wants to run a command to install dependencies, so I'll allow that. Next, it wants to run Flutter Analyze, which I didn't even know existed. The analyzer finds a few issues, nothing critical. The AI is now applying fixes to main.dart. All of this is happening autonomously from a single prompt. Very impressive. Okay, everything seems complete. I'll stop here for now because I still need to add native libraries before running the app. Let's open Xcode and add the libraries. First, go to the General tab and add all the llama libraries along with libchat. Then go to the Build Phases tab and remove everything except the framework. For more details, check out this video. Finally, copy a model file as model.gguf as specified in pubspec.yaml. I'll just symlink a llama3b instruct model. Alright, moment of truth. Let's run the app on the iPhone simulator. Okay, the app has launched. It takes a bit of time to initialize, and we are in. Let me type a prompt. The enter key isn't mapped to send, but that's fine. I'll click the button. The chat isn't super responsive because the API doesn't support streaming. Not the best user experience, but it's perfectly functional. Nice. Let's test whether this is a continuous chat session. And yes, it is. So we just built a minimal ChatGPT app for the iOS in Flutter without writing a single line of code ourselves. One thing that genuinely surprised me was that all of this AI-generated code compiled and ran without a single error. The model wrote multiple files in C, C++, and Dart, and they all just worked. The other surprising part was the cost. It took 2 sessions and cost me just 49 cents while saving hours of manual work, which makes me wonder what the long-term impact of AI coding assistants will be on software development as a whole. Are these tools just productivity boosters, or do they fundamentally change what it means to be a developer?